All right, so we're going to start out with our Journal 12 here, and we are going to be doing something called solving systems of equations. And in this chapter, we're going to talk about 3 methods for solving systems of equations, and the first one that we are going to be learning is graphing. Let me just explain for a moment what are systems of equations. So we've been working with piecewise functions where you have 2 or 3 equations and you're trying to graph them, right? Well, systems of equations are kind of like that where you have 2 or more equations. So a system is like having either 2 equations, 3 equations. It has like basically a clumped up equation, like a grouping of equations. So in this case, here it says, using a graph, you can find the solution for 2 linear equations by seeing where they blank. So how am I going to explain this is if I were to be talking about, just any graph here, I'm just going to draw a little picture. Actually, I'll do it down here. So if I was talking about a graph here, right, a coordinate system, and I had a graph, a line, so one of the linear equation gets graphed on. I'm just going to make a quick sketch here. So here's one of my linear equation. Here's my second one. When I'm talking about finding the solutions of 2 linear equations, well, if you have a line here and a line here, a solution is talking about where do those equations equal each other. And that's hard to see until you look at a graph here. So on a graph, it's where they intersect, like these 2 lines are doing. So that there is representing a solution for those 2 linear equations. What that means is that point has an x and a y value that these both lines meet at. And so we call that, so we can tell by seeing where they intersect. Now, like I said, graphing is one of the methods that we are going to be using for solving systems of equations. And so when you're graphing, we've done a ton of graphing before. The number 1 step when you graph is to make sure the y is by itself. So the y needs to be by itself so that you know what the slope is and you know what that intercept is. Because if you don't know how to graph your points and you're going to look stuck. And then the second part is to graph both functions because you have at least 2 functions. Sometimes you have 3. And then when you find your points, so once you graph them, you're going to find the points where the 2 lines intersect, like this point here that intersects both lines. So we're going to practice this here in a moment, but before I do that, I'm going to show you 3 different situations when you graph a line that could happen. So let's take a look at our next slide here. All right, so here are 3 situations that you could have. So there is this one here where it intersects at one point. That should say at. Let me fix that, or just let me white that out. That might be better. So just like the first graph that I was drawing before, where, sorry, I'm distracted. So intersects at one point, where I draw 2 lines, they intersect and meet at one point here, like you can see on the graph. Now, when you see one intersection, that means you only have one solution. So this only has one solution. So intersections tell you how many solutions a system of equation or 2 equations have. And then these 2 lines here look like they're parallel, right? So they're parallel lines. When you have parallel lines, they will run along each other, but they should never cross, right? Parallel lines will never cross each other because they have the same slope. So in this case, when they are parallel, parallel lines never intersect. Well, if they never intersect, that means there's no intersections. That means that there are no solutions because there are no x and y values where both of the lines are going to equal each other because they never cross, right? And so then this one here, it's kind of hard to see, but basically I've drawn a line on top of another line, and they are exactly on top of each other, which means that they are the same 2 lines. And this happens, like I give you 2 equations and they end up having the same slope and the same intercept. And so they end up being the same lines that you draw on the graph. Well, if you have 2 lines on top of each other and you were to ask yourself, where do they intersect? They're going to intersect everywhere. So these are the lines. So if you have same lines, the lines intersect everywhere. So in this case, if they intersect everywhere, that means that we're going to have infinitely many solutions, or all solutions. However you want to say it, infinitely solutions, but I usually just call it infinitely many solutions. And that's it for today's journal here. So in the next slide, I'm going to be doing problems from packet 3, page 1, problem 1 and 3. So I'm going to go to our new packet and go to page 1, problems 1 and 3. So this, you don't have to put in your journals. You can just write it on your packet, your homework packet. Okay, so in this example here, like I said, this problem's from, I'll write it here. Let's see, grab a blue pen. So this is from packet 3, page 1. So in this problem here, we have to check whether the given order pair is a solution to the system. So here's our system, because we have two equations here. So it's going to be, I'll call this one 1, this one 2. You guys are used to me color coding and numbering things. It just keeps things organized and helps me explain to you guys which one I'm working with. And so we have a order pair, just means that we have a coordinate point, and coordinate points are just your x and your y value. So they want to know if this x and y value are solutions to these two equations. Well, the way we're going to know is if we plug them in and it actually gives that number that's on the other side of the equal sign. So if I plug in 6, if I plug in -1, do I actually get 25? And if I plug it into the second one, do I actually get -16? So the best way to do it is just plug it in and work it out and see if I get those actual values. So I'm going to start with the first equation here and just set that up. So I'm just plugging in 6. And then I have -1 for my y. And I need to make sure that it equals 25. So I'm going to put a question mark on that equal sign because I don't really know if that equals yet, but I will. So in this case, 4 times 6 gives me 24. 2 negative signs on this one makes it a +1, right? And then in this case here, 24 plus 1, and then I just drag this 25 down, but 24 plus 1 is 25, and 25 does equal 25 on the other side. And so in this case, this here is a solution, right? I did get the number on the other side. So this order pair does work for the first equation, but we need to double check that it works for the second equation as well. So one more time here. So -3 times our x, which is 6, minus 2, times our y, which is -1, equals -16. Let's see if this is true. So if we're working this out, -3 times 6 is going to give me -18. -2 times -1 is going to give me +2. So let's think about it. Does this really give me -16? Well, -8 plus 2 does, in fact, give me -16. So -16 does equal -16 on the other side. And so this here is correct as well. So because both of these are correct, I can say yes, yes, this is a solution. Now, let's play out a scenario where I got this one right, but then I worked this out and this one didn't work. Well, that means that in that case, this is not a solution. Or even better, let's say I was working out the first one and I hadn't even done the second one. So I was working out the first one and that one was not a solution. Well, then I could just stop right there and say it's not a solution. So here's the thing. In order to be a solution, both of the equation in the system, or all the equation in the system, need to be true. If it's not, then it's not a solution for the entire system. And that's pretty much it for this one. So definitely try out number 2 when you get the chance. It's very similar to this problem. But I'm going to move on to number 3 and do a graphing problem for you guys. All right, so with this problem here, what I'm going to do, remember the steps are to first, number 1, get the y by itself. I can never graph something if I don't know what the slope is and the the y-intercept. So I'm going to go ahead and number these because I have two equations. This is our system of equation. So our first equation here is the 2x plus y equals 6, and I need to get this y by itself, so maybe I need to move over this 2x. So if I move that over, that's 2x minus on both sides. That allows me to cancel this side, bringing down the y. Now, 6 and negative 2 don't combine. Remember, we'll just bring them down the way it is. So I have a negative 2x plus 6, or if you want to write it as 6 minus 2x, that's also fine. I know some people like to see the slope in front and then the intercept. But this equation here, notice how y is by itself, so now I can graph it. So my intercept here is 6, so I have to go up to 6 and plot. And then my slope here is negative 2 over 1, right? Based off of this equation. So in this case, I need to go down 2 over 1. And this time, because I'm trying to estimate this solution, supposed to estimate this solution, I'm going to plot more points, because here's the one downside about graphing when it comes to finding solutions to systems of equation, is that graphing depends on your drawing skills, right? And so sometimes your drawing skills might not be accurate enough. So it's always better to plot more points when you're doing linear systems of equations, just to plot some more extra points, because the more plots you have, the more points you have on the graph, the more accurate your line, or how straight your line is. Notice how my slope here helps me guide my lines, right? And so now that I've plotted that line here, I'm going to now plot my second line, so I have to find the slope and the intercept, so I have to get that y by itself first. So maybe subtract the 3x like how we did before. And so this side would cancel out. We have negative 2y equals negative 3x plus 2. And then I'm going to be dividing by negative 2. But when you divide by negative 2 on this side, you need to divide by negative 2 on both of the terms on this side. Okay, so be careful there. So this will cancel. Y is equal to, well, let's check out our slope here. Negative 3 divided by 2. I can keep that as a fraction because that's my slope. That's a positive 3 over 2x. And then if I have 2 divided by negative 2, you get negative 1. So in our case, our equation is 3 over 2x minus 1. So our intercept is negative 1, which I will go ahead and plot on the graph. And then our slope is 3 over 2, so that means up 3 over 2. Oh, up 3 over 2. That hits right there into the other line. It looks like that's the only intersection that I could possibly make, because, you know, the other line just going this way, where this is just going to cross it, looks like at one point. Now, at that point there is going to be also our solution point. So that point looks like it's 2, right? We always write our x. Keep in mind, we always write our x first, then our y. So we can say our solution is at, I'll just write at 2, 2. And looking at this type of graph here, it looks like we only have one solution. So oftentimes you'll hear me say like, oh, what's your intersection? And you'll look at the graph and find what the intersection, but I will also ask you like how many solutions there are based off of the graph, or based off your arithmetic. So that's it for this video here. I hope that helps with your homework, and try out all the other problems on page 1.